Hi friends, welcome back. I struggled with probability for the longest time. I really didn't know how to be reading these. There's so many terms like mutually exclusive, independent, dependent, conditional, that kind of thing. So here are some notes that I think will be helpful, and I'm going to try and break them all down for you. The first is exclusive. You can, and so just pause the video and write all these down. And means multiply, or means add. Not exclusive means it can fill both requirements. Exclusive means it can only fill one of those requirements. So an example here, exclusive. A marble drawn can only be one color. So you have a bag of marbles. You can't have a marble that is both red and blue if you're doing like single color marbles, right? However, not exclusive would be a card that's drawn that can be both red and a queen. You can have cards that are both red and queens. There's two of them, in fact. So that would be not an exclusive one. The example for and. Like I said, and means multiply. So you draw a marble that is blue and you draw a marble that is green. You're going to multiply those two results together. The or means you add. You draw one marble, chances it is blue or green, means we're adding those two opportunities together. So I'm going to get into some examples about that so that you can kind of tell the difference. All right, like example number one, we have a bag of marbles here. I want to draw with replacement. So we're going to draw a marble, we're going to put it back in, and then we're going to draw another marble. So the probability we draw a red and then we draw a green. Well, the probability we draw a red, that would be 7 out of 30 because there's 30 total. And that we draw a green. So and means multiply. So we're going to do a green, which is 6 out of 30. All right, this can be reduced if we cut it in half and cut it in half. Well, we can just divide by 6, we get 1. Divide by 6, we get 5. So that would give us 7 out of 150. So 7 out of 150. Now let's talk about without replacement. So we're going to do the same thing, but this time we're going to reach into the bag. What's the chance that we draw red, hold it, and then reach in and draw another one, and that is going to be a green. So our red is still the same, 70-30, but we're still multiplying because we're doing this and this, right? We want to do the red and the green, so we're multiplying. But this time we're not replacing it, so there's only 29 marbles in the bag. However, 6 of them are still green. So we would multiply, divide this by 6, we get 1. Divide this by 6, we get 5. So we end up with 7 over 29 times 5 gives us 145. Okay, so that's the difference between, replacement and not replacement, but you see the word this and this, right? And means multiply. Okay, so let's try another one. Similarly, this is the same example continued, so we're going to use those same numbers. We draw one marble. What is the probability it is green or pink? Now, or means add. So green is 6 out of 30, or pink, which is 1 out of 30. That gives us 7 out of 30 chances. So when you hear the words or if you can put the words or in there, that's going to be adding. Okay, so let's talk about these mutually exclusive ones. Probability that you draw a card that is a 4 or a 7. Now, you have to ask yourself, can a card be both a 4 and a 7? It absolutely cannot. So there's only 4 4s and there's 4 7s. So 4 out of 52 in a deck of cards, or means add, plus 4 7s. So we end up with 8 out of 52. And then we could reduce that, 26. So if we divide that by 4, we end up with 13. Okay, so yeah, so 13, 2 out of 13 would be 4 or a 7. All right, how about a diamond or a black? Can a diamond be black? No, it cannot fulfill both of those. So again, these are exclusive. So a diamond would be 1 out of 4, or because it's 1/4 of the deck of cards are going to be diamonds. Black is half of the deck. So that plus 1/2, I'm going to need a common denominator here. So we'll call this 2 over 4. So your chances are 3 out of 4 or 75%, right? Now, let's talk about this, a red or a 3. Okay, so or still means that we're adding. However, a red is half the deck, right? 1/2 of the deck, plus a 3. Now, there are 4 3s. However, we've already counted 2 of those 3s that are red. So we have 4 out of 52 minus 2 out of 52. Okay, so that leaves us with 1/2 plus, sorry, I should have left more room here. 2, that's 2 out of 52, which is 1 out of 26. So if we do plus 1 out of 26. So if I multiply this by 13, I would get 26, this by 13. So I end up with 13 over 26 plus 1 over, so 14 over 26. Cut those in half, right? And we end up with 7 out of 13. 7 out of 13. I didn't leave myself enough room. I'm very sorry about that. But the important part here is that I want you have to subtract the ones that are double. You can't double count them. So let's try another one of those. And this time look at plenty of room. A spade or a face card. Okay, well, a spade is going to be 1/4 of the deck, right? That's because there's 4 suits. So it's 1/4 of the deck plus a face card. Now, a face card, there are Jack, Queen, and King. There are 3 of them for 4 suits. So that's 12 out of 52. However, the spade and a face card, that's 3 that I've already counted. So I have to subtract those 3 out of 52 because I don't want to double count them because they were already counted in this part right here. So minus 3. So I get 1/4 plus 9 over 52, right? Now, 52 divided by, yeah, okay. So then to multiply this by 13, multiply this by 13. Now what I have is 13 out of 52 plus 9 out of 52. That's 22 out of 52, which is 11 out of 26. 11 out of 26. So that's what they mean when they say mutually exclusive. You got to ask yourself, okay, is there something that can overlap? Can they count for both of them? And if there is, you need to subtract it. So hopefully that helped explain probability a little better. If you have any questions, leave them below. Otherwise, we'll see you next time.